Hello friends, Harshal here and welcome to my YouTube channel. In this video, I'll explain you Elastic Beanstalk theory part. So I have extracted information from AWS documentation. So I'll explain the same. Here, what is Elastic Beanstalk? So you know very well that what is Elastic Beanstalk because recently I had made some videos. You can go and check it out, those previous videos. And we can easily deploy application without having any overhead of managing infrastructure. So here we just go through this information. So with Elastic Beanstalk you can quickly deploy and manage application in the AWS cloud without having to learn about the infrastructure and run those applications. So let us say if anyone has come up with one of the code, okay, if somebody has a source code or the application, then he can easily deploy application even if he don't know about how to configure the infrastructure, how to create the suitable infrastructure or the compatible infrastructure. If he don't have any knowledge about that, that is fine. Okay, you can simply go to Elastic Beanstalk and you simply deploy your code, okay, just on your fingertips. So Elastic Beanstalk reduces management complexity. Okay, so there is no much management complexity. You can see here in Elastic Beanstalk. Without restricting choice or control, you simply upload your application and Elastic Beanstalk automatically handles the details of capacity, provisioning, load balancing, scaling, and application health monitoring. Okay, so automatically Elastic Beanstalk take care of load balancing, scaling, and application which is required for any application running on EC2 instance. These components also is important, that is the health monitoring, load balancing, and scaling, right? So yeah, no need to worry about that. Now how to create Elastic Beanstalk environment. Okay, so here is, first of all, you need to create the application. Simply you need to upload your code, right? So while creating the application, you just have to upload your code. Then you can upload your version. Okay, upload version means you simply choose the version of the platform, okay, which platform you are actually using for running your code. So that's what you need to check it out. Then we can simply launch the environment, and later on we can also manage our environment. If you want to change the configuration, you can simply go to eb extensions file .eb extensions directory, and in that directory you can simply save .config file, okay, and you can do so much changes in that configuration setting, and as per the changes the overall infrastructure change according to that .config file. Then AWS resources created in EB. Okay, so there are so many AWS resources created when you are using the Elastic Beanstalk. Okay, some you can define what kind of instance you want. Okay, what instances you want, you can choose the reason. Okay, instance will be automatically created by the Elastic Beanstalk, but here you can choose the region where you want to create, and there are some specific you can choose or select. Okay, so let's go one by one. So EC2 instance. Okay, EC2 instance will be this resource will be created by Elastic Beanstalk. So an Amazon EC2 virtual machine configured to run web apps on the platform you choose. So whatever the platform we choose, we can simply whatever the platform is suitable for your code, you can simply choose that platform. Then instance security group. So the instance security group will be automatically created, and if you are choosing web server platform, web server application, then in the web server environment, in that case what happen, automatically port 80 will allow. for incoming traffic. Then Amazon S3 bucket, it will be automatically created a bucket storage location for your source code, logs and other artifacts. So related to your code, the source code will be saved in S3 bucket, logs will be saved in S3 bucket, and other artifacts that is generated after using the application, that too will be saved in S3 bucket. Now there is Amazon CloudWatch alarms. So again, that CloudWatch alarms also gets created. Two CloudWatch alarms that monitor the load on the instances in your environment and are triggered if load is too high or too low. When the alarm is triggered, your auto scaling group scales up and scale down in response. So according to the CloudWatch alarms, what happen when there is so much load on any instance? Okay, in that case, what happen? The auto scaling group will scale up the instance. The other instance will be created automatically due to the auto scaling group, and the load will be, and the load balancer will manage the load. So in that way, this will work. Then cloud formation stack. So cloud formation stack also will be created by the EB Elastic Beanstalk. So basically the complete infrastructure is created by using the cloud formation template itself. So every time whenever you are using any you want to deploy any code on Elastic Beanstalk, that in that case, the first of all, Elastic Beanstalk will create the cloud formation template, and on the basis of that cloud formation template, the complete environment will be created. Okay, now domain name. So the URL will be will also be, you will get the URL your domain name also, right? So simply just click on that URL and you can access your website. Okay, now the navigation pane. In the navigation pane, you can see a lot of stuffs, right? So okay, let me navigation pane, then clean up. Okay, so what I do, I simply go here and let me create one application, that is the test application. And here you can see the platform. Okay, the platform is PHP. Platform means what happened, that is we can call it a runtime. Okay, this is nothing but the runtime. So you can choose any of the programming language. So right now I'm choosing PHP. Then the platform branch, so that is the platform branch. Platform branch means what happened? Platform branch means the instances or the operating system, and this is the platform version. This is the major update, minor update, and the patch update. Okay, so in this way, the complete package of platform, runtime, operating system, then version. Okay, so then web application, server application, so everything come together, and we call it commonly we call it platform. Okay, now we will go with the sample application. It starts creating. Okay guys, so we have deployed an application. So here in the left hand side you can see that test environment. This is the URL which is created. Now the configuration, logs, health, monitoring, alarm, managed events, and these are the this one, where is that navigation page, right? So this one is navigation page. So let's talk about configuration. So shows the resources provision for this environment, such as Amazon Elastic Compute Cloud instances that host your application. You can configure some of the provision resources on this page. So we can actually configure some of the provision resources on this page. So here if I click on it, so there are so many resources. I can see I can actually configure the resources, right, by using here. Let us say if I edit this, then I can do so many changes, right? then there is a logs, so the logs will be generated here according to whatever the request we have got. Then the health, here we can check the health, so overall the health is showing okay. So if I go here in the documentation, so here health shows the status and detailed health information about the EC2 instances running your application. Let us say the application is running on this instance, so this instance should be fine, right? So this instance should be running fine, because if this instance is not running good, this instance having some hardware issues, some software issues, in that case what happen, we the user unable to display, user unable to access the web page. So that is why it is important. Okay, so health should always be okay. Then the monitoring, so we can do some basic monitoring. We have some 2, 3, 4 metrics. Okay, we can see the CPU, what kind of CPU utilization, then some request, and environment health. We can check with the environment health. So there are some max network in, max network out, so everything we can check out here in the monitoring. Then alarm, okay, we can go here and we can set the alarm. So this is nothing but the alarm. Okay, then manage update. So here there is no manage update for now. Okay, so we can manage update according to our situation. So for history we don't have it right now. Here we can also configure some changes. Okay, here is the manage update. So here this is disabled for now, and if you want we can do it here. And if we have done some manage updates here, then we can see same here in the history. Okay, now the event, we can see event here. The next one is tag. If you want to if you have set some tags, you can see here, and in fact you can add some tags here or remove the tags, right? Okay, okay. So then monitoring shows statistic of the environment such as average latency, CPU utilization. You can use this page to create alarms for the metrics that you are monitoring. So we can also create alarm. We can create alarm in the CloudWatch for the metrics that we are actually monitoring. Okay, then events shows information or error messages from the Elastic Beanstalk service and from other services whose resources this environment uses. Okay, then tag shows environment tags and allow you to manage them. Tags are key value pair that are applied to your environment. Okay, fine. Now cleanup. If you want to delete the complete environment, okay, in that case what you have to do, simply you have to delete all application version. Let us say you have deployed some application and you have done so many changes during interval of time. In that case what happened, different kind of versions will be generated, it will be shown. Then first of all you have to delete all the versions of the application, then we can terminate the environment. Okay, and after terminating the environment you can actually delete getting started application. Okay, so now you can use the following tools to create and manage Elastic Beanstalk environment. So we can create and manage Elastic Beanstalk environment by using CLI. Okay, so this is EBCLI and AWS Management Console as well. So we have used both of them, that is CLI and AWS Management Console. But there are some more options you will get, that is we can do it by using API, that is AWS SDK for Java, AWS Toolkit for Eclipse, SDK for .NET, then Toolkit Visual Studio, SDK for JavaScript, Node.js, PHP, Python, Ruby, right? So software development kits, by using software development kits you can actually create and manage the Elastic Beanstalk environment. Now the next one is Elastic Beanstalk concept. So there are so many elements you can see: application version, environment and environment tier, environment configuration, save configuration, and platform. So we will see one by one. So first of all, AWS Elastic Beanstalk enables you to manage all of the resources that run your application as environment. So it enables us to manage all the resources that run on our application on environment. So yes, okay. So first of all, let's check one by one. So that is application version, environment tier, environment configuration, save configuration, and platform. Okay, so if I go here and where is, okay, that is concept. So what is application? So application is basically a logical collection of Elastic Beanstalk component, including environment version and environment configuration, right? So that is the application. So it is nothing but the logical collection of Elastic Beanstalk components, environment version, and environment configuration. So everything will be defined here in the application, and that file should be in .g file, so that we call it application. Okay, so whenever you want to deploy application on the Elastic Beanstalk, that file should be compressed. That file should be in .g format. Okay, now next one is application version. So in Elastic Beanstalk, application version refers to specific label iteration of deployment code for a web application. So you know application version. Let us say I have deployed one application and I have done some changes in the same application. Then what happened? The another version will be created, and there will you will get the two version. Okay, the file should be the same, but we have done some changes, so that is why we will get a multiple version. So that is called application version. Now the environment. The environment is a collection of AWS resources running an application version. Each environment runs only one application version at a time. However, you can run the same application version or different application version in many environments simultaneously. Okay, so environment, you know that what is environment? Environment means the collection of AWS resources running in an application version, right? So what you are actually doing, so you are actually using a various AWS resources, and that is used to run your application version. So that is called the environment. So you have actually created the environment where you have to deploy your application or the source code, and that application will be running on it. Okay, now environment tier. So basically there are two types of environment tier, that is web server environment tier and worker environment tier. Okay, what happened? An application serves HTTP request, runs on in a web server environment tier. So web server environment tier. Okay, so web server environment tier, what it does, it serves the HTTP request run in a web server environment tier. So basically what happens, if anybody wants to access the web page, in that case or the application that is written in the HTML or PHP format, so that application would be deployed on and that must be deployed on web server environment tier, and all the infrastructure, all the environment will be created in that way, so that it is suitable to that particular code or the application. So that is web server environment. Okay, so it basically allow the AT port, that is HTTP port. Then a backend environment that pulls tasks from the Amazon simple SQL server queue, runs in an worker environment tier. So you know very well about worker environment tier. I have already explained about worker environment tier in my previous video. So please go and check it out, my previous video on worker environment tier. Okay, Then environment configuration. So environment configuration is very simple, that you are actually configuring the resources. You want to change the complete environment and the infrastructure that you want to create. So the environment configuration identifies a collection of parameters and settings that define how an environment and its associated resources behave. If when you update an environment's configuration setting, Elastic Beanstalk automatically applies the changes to existing resources or deletes and deploys new resources depending on the type of change. So you actually change the configuration. Okay, if you just click on the environment, let us say if I have created the environment name as test environment, test env, then what happen if I click on it, you will get in the navigation page configuration option, right? So simply click on that configuration option, and there you can change the entire configuration that you want. Okay, or if you want to change the configuration, there is another way. You can simply change the .config file in .eb extensions. There you can change in the .configuration file, and that change will be automatically applied by the Elastic Beanstalk. Okay, now save configuration. A save configuration is a template that you can use as a starting point for creating unique environment configuration. You can create and modify save configuration and apply them to C. You can create and modify save configuration and apply them to environments using Elastic Beanstalk console, AWS CLI or API, right? API means those APIs like API for Java, API for .NET, like those, right? The API and the AWS CLI refer to save configuration as configuration template. So basically we can save the configuration, whatever the configuration we currently have, we can easily save those configuration by running some commands. Okay, so I had already made a dedicated video on this, so you can please go and check it out. Now configuration. A platform is the combination of operating system, programming language, runtime, web server, application server, Elastic Beanstalk component you designed and target your web application to a platform. Elastic Beanstalk provides a variety of platforms on which you can build your application. So basically I told you while creating this application, while creating this environment, so whenever you create any okay, let me do one thing. I go to environment and create an environment. Okay, not this one. Okay, so whenever you create an application, okay, in that case what happened here, you can see the platform. So platform consists of the platform means runtime. This is the runtime. Okay, they have written here platform, but it is we can call it runtime. So it could be a Java, Go, Docker, it's a programming language, right? Plus what if you selected Java, then what, there is a platform branch, so that Java will be run on Linux or Linux 2, right? And here we can see, so what exactly happened, the instance will be created and the Java operating system and the Java will be installed on that instance, and there is some operating system is needed for running the instance. So that Linux operating system running on Linux operating system based instance running Java application. Okay, and because of that, and that is what we call a platform, right? So now next one is web server environment. So there are two environments, that is web server environment and the worker environment. So let me explain the web server environment. It is very important, right? The following diagram shows an example Elastic Beanstalk architecture architecture for a web server environment tier and shows how the components in that type of environment tier work together. Okay, so let me tell you. So okay, so this is the complete environment. Okay, and this is a different environment. Okay, both are in a different environment. Database is in different environment, and the complete platform and the complete infrastructure is in different environment. So if this environment goes down, okay, in that case what happen, that database will not get deleted. Okay, because data is very important. That's why we in the enterprises, that database has a separate environment, and the database will be taken care by the database team. Okay, so if you want to access the application, let us say here are the 4 instances, and every instance is running the running the application, right? So here you can see the security group. So first of all, security group allowing the port 80, okay, input port 80, so that anybody on internet can access the application. Okay, so that's why security group, right? Then you can see the second layer, that is auto scaling group. Here auto scaling group, what auto scaling group does, so let me tell you in a moment. Okay, so first of, before I'm telling you about the auto scaling group, let me tell you about the elastic beanstalk and how traffic goes in. Okay, so let us say every instance having the capacity, every server has the capacity of processing 100 requests. Okay, let us assume, right? So only 100 requests. So this instance process 100 requests, 100, right? So what happen if 1, 2, 3, 4 requests, that request will go to here from the load balancer, it goes to here, okay, to that server. And okay, so up to 100, so all the request, all the traffic, all the request will go here, and it will send in response the web page on internet, right? So in this way it happens. So until 100 requests, it will give a response. But after 101, what happen, that elastic beanstalk will route that 101 request on EC2, this EC2, second EC2, because the capacity of this EC2 is 100 only, or the load balancer is set in a way that the 100 up to 100 requests will be sent here, and 101st request will send here, and up to 200, right? So then 201 here up to 300, then 301 here up to 400. Then what happened, 401, in that case what happened, the auto scaling group will create automatically a new instance, right? Or let us say, okay, the new instance will be created, auto scaling, right? So 101 will be, so that is called scale up. 101 will be request sent to this 5th instance. Okay, so that is called auto scaling group. So auto scaling group scale up the instances. Let us say if this instance goes down, right? So there must be 4 instances, at least 4 instances should be running. But here, if this instance goes down due to some hardware failure or due to some different issue, okay, if this instance goes down, then what happen, only 3 instances is running, right? Only 3 instances is running, but minimum 4 instances is necessary, it is mandatory. In that case, what happen, auto scaling group will create a new instance, okay, so that the minimum 4 instance should be running at a time. Okay, and this instance, so the 4 instance will be running, and let us say this instance is come up now, so now there is a 5 instance. In that case, what happened, auto scaling group is scale down the 5th instance that was newly created, right? So it will be scaled down, and eventually the 4 instance you can see. So this is how it works, auto scaling group. Okay, and load balancer will route the load. Okay, according to there are different load balancer, application load balancer, classical network load balancer. So according to the request, it will balance the load. Okay, then availability zone, it means the region. Okay, the complete environment is we have created on what region. Okay, and in every region there is a different availability zone. There could be a 2 3 3 4 availability zone. Okay, right. So in this way it will work. Okay, so here you can see every environment has CNAME, that is URL. Okay, so this environment also has CNAME, or we can call it URL. Okay, this is the URL, myapp.elasticbeanstalk.com. So this is CNAME or the URL. It points to a load balancer. The environment has URL such this URL alias route 53 to an elastic load balancing URL. Okay, so actually this is not the actual URL. The URL is in the Elastic Beanstalk. Okay, so this is the route 53. Okay, so AWS route 53 will change the URL that we want. Okay, according to our necessity. So here, okay, the highly availability and scalability domain name system web server, yes, we can call it DNS. It provides secure and reliable routing to your infrastructure. Your domain name that you registered with your DNS provider will forward requests to the CNAME. Okay, and then everything we have already discussed, that I have already tell you. Okay, so everything will be like the same. Okay, the host manager is responsible for the following. So you can see here host manager, right? So in every instance you can see the host manager. The host manager is nothing but the daemon, right, which is constantly running. Why it is running? Because let us say if how do we know that this instance is running? What is the problem with this instance? Okay, if you want to monitor these instances, then what happen? There should be some data required. Okay, so this is why that the host manager is responsible for the below things. Okay, the host manager deploying the application, it is the responsible for deploying the application. It is responsible for aggregating events and metrics for retrieval via the console, the API or the command line. Okay, then generating instance level events, it generates the events. Okay, it monitoring, it is solely responsible for the monitoring the application log files for critical errors, then monitoring the application server, patching instance components, then rotating your application's log file, publishing them to Amazon S3. So according to that it will work. So hope so you understood this diagram completely. Okay, so this is the host manager, right? Host manager. So every instance has host manager, so that we will get data at the interval of time, at specific interval of time. And there is a auto scaling group, security group, then load balancer and auto scaling group. It will work as a unit. Then there is a route 53 which is used for the CNAME or the URL or the DNS. It will deal with the DNS and Amazon availability zone. Okay, and whatever the data require, whatever the web page is, whatever the data it require any user, then what happen? It access that that website, and in website if they click, if they want further data, they it will redirect it to the database, right? So according to that, you know that tags, we can add the parameters as well, right? So whatever the parameter we define, that it will refer to the database, and this is how it works. Now then go to worker environment. Here I simply tell you about this diagram. Okay, so let us say any on internet any user wants to access the application, right? So it will go through the elastic load balancer, then that load balancer will send a request to EC2 instance. Okay, and that EC2 instance, what happen, it will send SQS queue request, SQS message to that AWS SQS queue, and from there it will send the SQS message to here, to that the next instance, right? Or the worker environment tier. So according to that, it will send data, using HTTP post. So there are HTTP get and HTTP post. So if you have a small amount of data, then we will use HTTP get. But if you want to send I mean a big amount of data, right? So in that case we use HTTP post. So using HTTP post, it will send the data, okay, a big amount of data it will send, it will process, okay. And here you can see that SQS daemon is also, SQS queue daemon is also running on this instance, okay, in this instance. So in this way it will work. It is the same, only thing is that it will send a request through SQS queue, right? So here we will see, okay, when you launch, okay, so from here we will read. So when you launch a worker environment, Elastic Beanstalk install necessary support files for your programming language of choice and a daemon on each EC2 instance in auto-scaling group. Okay, it will send it will install the necessary support files for your programming language of choice and a daemon. Okay, it will install a daemon as well on each EC2 instance in auto scaling group. So what is daemon? Daemon is the background process which is running at every interval of time, so that is, we call it a daemon. So the daemon reads messages from an SQS queue. Okay, it will keep on running in the background, that is why we call it a daemon. It will read the messages from the SQS queue. The daemon send data from each message and it reads to the web application running in the worker environment for processing. If you have multiple instances in your worker environment, each instance has its own daemon, but they all read from the same Amazon SQS queue. So daemon is basically required for reading the Amazon SQS queue. Okay, so here you can see that SQSD, it means that SQS daemon, it will read the SQS queue, right? So let us say there is a Amazon SQS queue and it will send a message. So what happened, this daemon will keep on checking, if we have getting any message, if we are getting any message, then it will send the data through HTTP, a big amount of data through HTTP post, right? So in this way this will work as a worker environment tier, in a worker environment tier. Okay, so now okay, now there is a last, that is design consideration. So the Elastic Beanstalk is basically designed in a way that it will get a scalability, security, it has a security by default, then persistent storage. We can use persistent storage. Amazon S3 is a persistent storage, AWS S3 is a persistent storage, then we have got EBS as well. Then fault tolerance, software updates and patching, we can do it. Then the connectivity, so everything we will get if we use Elastic Beanstalk, because it is actually designed in such a way. Okay, so I hope that whatever I tell you in this video, whatever I explain you in this video, so you got the idea. So guys, thank you so much for watching my video. Have a good day. Bye.